Part 4. In this problem, theta is an acute angle of a right triangle in the first quadrant. I know that the cosine of theta is k over 11, and I know that the sine of theta is 3 over 11. That means that when I draw my triangle, the adjacent side is k, the opposite side is 3, and the hypotenuse is 11. Since I want to find k, I can just Pythagorean theorem the equation. So k squared plus 3 squared is 11. Square my 3 and my 11 and get 9 and 121. Subtract the 9 from 121 and get k squared equals 112. And then square root both sides. K is the square root of 112. In question 10, I have to derive the identity tangent theta plus cotangent theta equals 2 cosecant 2 theta. The first thing I do is I change tangent to sine over cosine and cotangent to cosine over sine, because that'll make it easier to work with. Since I'm adding fractions, I want to find a common denominator, and the common denominator is sine theta cosine theta. So I multiply the first fraction by sine over sine, getting sine squared in the numerator. In the second fraction, I multiply top and bottom by cosine, so I get cosine squared in its numerator. And now I have a fraction with common denominators. I can add them and get sine squared theta plus cosine squared theta over the common denominator of sine theta times cosine theta. Remember that sine squared plus cosine squared is a Pythagorean theorem identity for trigonometry, and it's equal to 1. So 1 over sine theta cosine theta. Now I have to figure out what to replace sine theta cosine theta with, and luckily I remember my double angle formula for sine. So setting sine 2 theta equal 2 sine theta cosine theta, and then dividing both sides by 2, I can replace sine theta cosine theta with 1/2 of the sine of 2 theta. Now I have a reciprocal, and 1 over 1/2 is 2. 1 over sine 2 theta is cosecant 2 theta, and I've proven my identity.